everyone. Today I'm going to be talking through my presentation for Lab 2 for Physics 2211, which was about the drag force on falling objects. Introduction. The purpose of this lab is to determine the effects of drag on an object that is falling from a certain height. Newton's first and second laws of motion are depicted in this experiment. The first law says an object will only change in motion if a force is acted upon it. In this case, the weight force, modeled W equals negative mg. The second law states that the force on an object is equal to its mass times acceleration, modeled F equals ma. Drag force is also a fundamental principle in this lab, modeled Fd is equal to negative b v squared times v hat, where b is a proportionality constant and v is the velocity of the object. The results of this lab show that a model in which the drag force is proportional to the square of the speed closely resembles the motion of the experimental data. So this was the video that I used in my experiment. Models. As stated previously, the purpose of the experiment is to determine the effects of drag force on an object. The only two quantifiable forces acting on the paper ball in my experiment are the weight force and the drag force. In the experimental model, we can see the ball fall to the ground in a nearly linear path vertically. Experiment. The initial conditions include the time, which was 0 seconds, initial position of 0 meters, and initial velocity of 0 meters per second. The system was the paper ball, the earth, and the air. The surroundings were everything else in the universe. Using Tracker, I was able to track the motion of the ball in the y direction, and I also adjusted the axes when tracking to make sure the y axis was on the motion of the ball so that the angle wouldn't affect the data that I collected, because the ball did not fall perfectly straight. As the graph shows, the motion was plotted to resemble an exponential function. This aligns with the theorized motion as the object has acceleration. So as you can see here, the motion of the ball in the y direction is exponential. There were two models of code for this experiment, one with only the weight force acting on the object, and the second with both the weight force and the drag force acting on the object. Line 71 here shows the physics model for the weight force, which is W equals, here in this case, negative ball dot m, which is the mass of the ball, times g times j hat, which was the vector of the motion. And line 72 here shows the model for drag force. In this case, it's negative b times the magnitude of the ball's velocity squared times v hat, which I made a new vector where it is in the opposite direction as j hat, or the weight force. In this model, with only the weight force, the value of b here in line 57, which is a proportionality constant, was 0, which made the value of drag also 0. However, for the second model, the value of b equals 0.003 most closely resembled the motion of the object in the experiment. Discussion. As shown in the chart, we can see the predicted positions and observed position plotted against time. So the predicted position with no drag is in blue, the predicted position with drag is in orange, and the observed position from the experiment is in red. The graph shows a difference between the model with no drag and the experiment, which can be accounted for the drag that exists in the experiment. However, the model with drag is nearly identical to the observed data. And there could also be error in this area right here in the physical data due to perhaps a breeze or outside disturbance in the room, or the shape of the ball, as it was not perfectly spherical. Discussion. So what does it mean question? As these two graphs show, the velocity is linear when there is no drag, but exponential when there is drag. The second model can predict a terminal velocity, which is when the magnitude of drag is equal to that of the weight force, so the net force becomes 0. The asymptote of the second graph, which is about here, can show the velocity at which the object will be terminal. So the what if question. if the object was thrown down, the terminal velocity would still be the same because the only things affecting terminal velocity are the mass of the object and the acceleration due to gravity in this case. So therefore, the drag would reduce the velocity of the object, or the magnitude of the velocity of the object, until it reaches the asymptote value. Conclusion. In conclusion, this experiment showed the effective drag force on the motion of an object. I demonstrated Newton's first and second laws and showed relationship between the weight force and the drag force. And finally, the computational model I developed was nearly identical to the experimental model. Thank you.